Hey guys, wanted to do a video today on provably fair raffles in this instance, but it can be applied to provably fair anything in crypto. I got involved in Bitcoin and cryptocurrency years ago, back in 2012, predominantly because the Federal Reserve is the most corrupt system on earth, and by extension, all central banking. Um, in my opinion, it's the reason we have a two-party system. A two-party system. I got the air quotes going up. Endless wars, endless welfare. Um, in my estimation, I think, or in my opinion, crypto is going to help free a big portion of the world from the evil central bankers. So, Bitcoin kind of got its legs, obviously, on the Silk Road. The drug site set up by Ross Ulbricht. God bless him. Poor guy is serving a life sentence in jail just for managing a website. And it also got its legs on gambling. So, I grew up in a household where my dad owned racehorses, my uncles owned racehorses. I was at the track every day, so I always loved gambling, and I stopped calling it gambling at a very young age. I've always referred to any wager I make as an investment. I consider people who put money in the stock market gamblers. Anybody who has an option is gambling. Gold or silver is even a gamble. I mean, look at the RICO charges that were just brought up on J.P. Morgan Chase against fixing the silver market. So I've always bought a lottery ticket here and there. Nothing crazy. I'll buy a few bucks a week. But one of the things that's very concerning about a lottery system is, first off, is that it's not fair, and it's been proven to not be fair throughout the years because many people have been arrested for either cracking the random number generators, the RNGs, through what's called seeding. Most RNGs, I don't know, is a shout out to the old Commodore 64 users, and actually even a lot of the common libraries that do so-called randomness. A lot of random numbers are generated with a seed, and so a lot of the casinos have been beat this way, and there have been straight up theft in lottery just because people have either just hijacked the seed, or they've straight up embedded their own random number generator with custom seeds that they can predict numbers that are coming. So there's no fairness on that end. And secondly, and more importantly, aside from or not more importantly, but just as important, aside from the fixing that goes on in the non-fairness arena, there's a 50% take, and then more than that when you count the taxation. You're often left with 25% of the or less of the entire pool after the states take, and the government's take through taxation. Uh, so crypto is going to solve that challenge and level the playing field, and it will be unstoppable. I mean, it's currently unstoppable. There will be no way for government to stop it. So, I mean, I kind of see a day when there's a worldwide, DApp uh, lottery, or a raffle, as I like to call it, where people from around the world can participate, knowing that it's provably fair and untaxable. So imagine a world of 7 billion people, and let's imagine each one puts in a buck or $2. You'd have a 7 billion to $14 billion pot just on that alone, and knowing that you'd get, let's say, 99% of the pot, and you wouldn't have to pay tax on it. People would be putting in much more than $1 or $2. So, and again, I understand for those being nitpicky that, right, it's 7 billion people, includes a good number of children who probably wouldn't know how to, use the computer or, have access to funds or DApps. So, yeah, I get it. I'm just doing rough estimates here. All right, so let's assume that we want to build our own Provably Fair raffle. Now, I've already built my own Provably Fair raffle on the Next system, and then I ported it to Burst. But I left it run in the wild for a good amount of time. I never got any legs. I didn't really try to market it. I was just kind of reticent with law enforcement and people that could kind of shut that down. Now, the reason I say that it can't be stopped in one context, but that I was reticent of law enforcement in the other context is that I built a centralized, provably fair raffle system. So it was dependent upon my application doing the processing. With DApps, decentralized applications, that's not a concern because nobody can stop that. Once it's running in the wild as like an Ethereum smart contract or as a Waves smart contract or Lisk, or one of these cryptocurrencies that has a decentralized I was about to say Turing complete language, but it doesn't matter if it's Turing complete or not. But as long as it's a decentralized app platform, then you can run a provably fair raffle. So it's really simple, and that's what I wanted to kind of go over today is kind of the outline with the basic math behind it to show just how simple it is. I'm not going to get into any coding. I have done other videos on coding crypto, and you can kind of marry the two if you have a desire to build something like this. But I would recommend, if you are going to build a provably fair raffle, I would again recommend building an Ethereum decentralized app. They call it DApps for short. So either on Ethereum or Waves or Lisk. I am kind of leaning towards Waves at the motion. I've looked at Solidity. I personally, find it a little difficult to comprehend. Plus, every time someone pushes a DApp, it's almost like instantaneous that some good-hearted developer finds flaws in the code. And unlike a centralized application where you can just shut down the app and do a code fix and then go live again, with a DApp, it's not that simple. You can't just shut down a decentralized application. Once you shut it down, it's got to be shut down for good. And you kind of have to let everyone know that hey, don't send funds here because they'll be stolen. So I'd probably lean a little bit more towards Waves or Lisk. And even though that their DApp language is not as robust yet, my gut kind of tells me Waves is kind of where it's going. So, all right, let's say we're going to build a provably fair raffle, and we need to work out the framework on the mathematics behind how this would work. So this is really just to kind of get your head around how you make something provably fair. Now, I'm definitely going to get, if I get more than 20 views on this video, anybody who kind of knows basic math will kind of jump on me for the provably fair aspect of it. And to them, I just say, just kind of hang in there. And also, there's some factors that most people that have argued with me that you're not taking into account. And so when we get to that point, I'll speak to it a little bit. But it's as, I'm not going to say it's as fair as you're going to get. It's definitely provably fair, and I'll kind of dig into why. All right, so if we're going to build a provably fair raffle, one of the first things we need to keep track of is like an index mechanism. So we'll, and I'm going to share this Google Sheet in the video, so don't worry. And I've got the an educational tab and the master tab. Master tab was where I staged everything before I jumped in here, just to kind of ensure that I had all my ducks in a row. But you'll be able to see both sheets, and by the end of this, they should look extremely similar. All right, so we want an index, and the index is to kind of give us a placeholder for the range of tickets that are bought to this raffle. All right, so I'm just going to do some quick formatting here, just kind of center everything. So because we're going to be doing modulus and things like that, we don't really want to have to add numbers like add 1 to the natural index of a modulus. So we'll just keep the index at 0. So the first ticket that's bought, that index is 0. Okay, so we're going to start our counter at 0, and then we'll say tickets purchased. Okay, and this would be some random person from around the world who has um, sent coins into our D app to purchase tickets. So let's say you're allowed to purchase as many or as few tickets as you want. But let's say that for this purpose we're just going to have between 1 and 50 tickets purchased, or 1 and 100. A lot of these cryptocurrencies are fractions of a penny. So some people might buy thousands or tens of thousands or millions of tickets just because the price might be super low. Let's say we even set the ticket price at a penny. All right, for the purposes of this, just to keep this simple, we're going to set the ticket price just at one. So one is an arbitrary number. It could be $1, it could be one crypto, but it's one for these purposes. All right, so we get a random number. This person purchased 72 tickets. So this person now would then have tickets from index 0 through 71. You see, because we're starting at index 0, they purchased 72 tickets, so they would go from 0 to 71. Actually, that's not right. It would be 0 to 70 because if it was one ticket, their index would be 0 to 0. Yeah, so we want to, and I just lost my train of thought there. So ticket 2. Okay, this is good. It's actually a nice low number on this one. We can actually count it out. So we'd have index 0 to 3, right? Because 0 would be the first ticket, 1 would be the second, 2 would be the third, and 3 would be the fourth. So it's basically this, the index, plus the number of tickets purchased, minus 1. Oops, I forgot to put in 1. Okay, so in this case, this person purchased 65 tickets. They have tickets from 0 to 64. If this was one ticket, this would show up as 0 to 0 because you only have one ticket. Okay. All right, so we can build out a list, and we'll go down. We'll keep it on the screen. So we're basically going to reset the index at the ticket 2 purchased plus 1. Oh, my unlock is off. Plus 1. There we go. Okay. And then we'll just copy this down here. And then we'll copy this out down to like here. That's fine. Okay, so now we have an idea of people that have participated in this raffle. So we've got a number of people that have purchased tickets to this raffle. This person purchased 81. They've got index 0 through 80. This person has purchased 59 tickets, so they have ticket numbers 81 to 139, all the way down to our final ticket purchaser who has ticket 1508 to 1577. All right, great. So now we need a mechanism to figure out how to incorporate the provably fairness into this raffle. Now, I am going to use transaction IDs. And I've gotten into it with a few people over whether or not transaction IDs can be used in a provably fair manner or not. And the only argument that I've ever received as to why they cannot be used in a provably fair manner is that transaction IDs can be predetermined. And I said, yeah, that's fine. A predetermined transaction ID is absolutely fine because you don't know if other people are going to submit raffles either prior to you. And so that would throw off all of the calculations for your predetermination. And, so I believe transaction IDs can absolutely be used in a provably fair manner. There are other mechanisms that are used. If you look at Satoshi Dice and some other sites that were kind of in that vein and are still out there running in the wild. Um, they use they will generate a seed, and then they'll reveal the seed, and so that's another way to do provable fairness. But in a raffle, I generally think that using the transaction ID is safe strictly because of what I mentioned. Now, the transaction IDs that we're going to generate, these pseudo random transaction IDs, would not theoretically be the best approach just because they're going to be smaller numbers. And they are going to be smaller numbers just because to do modulus in Sheets, Google Sheets, or Microsoft Excel, there's a limitation of I think it's like 15 digits. So you can't really do modulus above anything that's 15 uh, 15 characters, 15 numbers. So whatever that is, that would be, let's see, millions, billions. Like I think your limit's up to about a trillion, maybe a little bit more. So with a real transaction ID, it would be this huge, long, hexadecimal number. And you would use a system that could handle those large numbers. I mean, Python easily handles large numbers like that, and it doesn't care if it's hex or decimal. It doesn't matter. But for this example, just suspend belief. We're gonna make this a small um, transaction ID. So we'll say transaction ID, and then we'll use the rands between again. And the way that I staged this was, I wanted to ensure that we had at least the max number of tickets. So at least these numbers and higher of randomness. So this is 4 digits long, so I wanted to have at least 5. So that we spanned the entire scope of the total potentiality of number of tickets that were going to come into existence. And so when you look at the master sheet, you can see I used like a basic log formula, like exponential formula to, have this thing calculate on the fly. But because, I can see the scope right now, it's generally going to run into the thousands. We'll just make sure that it's at least 5 digits. So we'll make sure this number starts out at a low. This transaction ID is at a low of 10,000, but no higher than, 99,999. So just shy of 100,000. Okay. And we'll copy this down. All right, great. So now each of these people who have purchased tickets also have a transaction ID associated with their ticket purchase. And, this is standard in crypto. Anybody who does any kind of crypto knows that, you get your transaction ID every time you do any type of transaction in crypto. Sending and receiving crypto, you have your transaction ID, and it's typically a 60 character long, 50 something character long hexadecimal address that is used by the blockchain to verify that transaction is real and is embedded somewhere in the blockchain. So, all right. So now comes the easy part. Now we want to figure out, out of all of these tickets that are purchased, which one is the winning one. So let's say that, the rules for our raffle are that after 1,426 tickets have been purchased, and that's what it would be. It would be 1,426 just because the index is 0, so we'd have one higher. The raffle closes, and the winner is estimated. So we're going to use the transaction ID, the modulus of the transaction ID, to figure out who our winner is. So we'll first sum up all of the transaction IDs. Okay, so you can see we got a sum here. And then we want to do the modulus of this number on the total number of tickets. So we're going to just copy this down one more just so we get the total number of tickets. We could have hard-coded it, but that's fine. So we'll just say the modulus, the modulo And then the dividend is the bigger number, the sum of the transaction IDs. And the divisor is going to be the scope that we want. So we want to find a number between 0 and 1616 in this instance. And this will change because these are all randomly generated numbers. Okay. And there we go. So now we have our winning ticket is 1732. Oh, I'm sorry, 1118. So that would be this person right here. This person who purchased 69 tickets. So we'll just quickly we'll do some quick number formatting in Google Sheets because it's super easy. So we'll do, I forget how to do it, conditional formatting. Yeah, there we go. So we're going to say, we're going to do a custom formula. And it's extremely similar in Excel to do stuff like this, conditional formatting. It's very simple and very basic. So we're just going to say, and if A2, so if column A2 is less than or equal to the winning ticket, so we're going to make it absolute, so cell E3, and it's also C2 is greater than or equal to E3, and then we'll tell it just to turn green. And you can see how the geniuses at Google have it apply even before you click done. So thank you, Google geniuses, for making life super simple and building in these tools. So I'll click done because that highlights the row that has our winning ticket. And I'm just going to hit the delete key a few times just to generate new ones. And you can see we get the winning ticket every time. And then at this point, our DApp would recognize the winning ticket and the address that it was sent from. In the case of like Ethereum, you're always sending from the same address. So, the funds would be received at the address that you sent from. Cryptocurrencies like Bitcoin and Dash and Litecoin, they will typically generate a new address every time you do a transaction. And for some reason, the smart contract type coins like Ethereum and Waves and the other coins, Burst, Next, they do not generate new addresses. You use your seed, and your seed is not, it doesn't change. You just use that seed and use that address. I know there is some theoretical danger in doing that, both from having people figure out who you are, and also from an approach of like SHA-256 getting hacked at some point, or reverse engineered, or becoming quantum resistant. I've heard some discussion about that. I don't know what the what the actuality is, but is what it is. In this instance, for our DApp, it would work perfectly because, we wouldn't need to build a user interface layer for, staging all of this and showing who the winner is. Now, we might do that just so that we can show this data, but, as long as the methodology used is standardized, anybody could look at the data and then figure out, from a fairness perspective, who won. And, there's no disputing that this was done in a fair manner, and that, this person would get their funds. The likelihood is nobody knows who this person is. So this person would get, either the sum total or, a fraction of the total, hopefully close to 100%. You would assume whoever set up the smart contract would, the initial person would probably take a bigger take, but that code is going to be open source, so people would copy it, and we would get very close to a 100% return over time. And this is going to happen not only with games like this that we just staged, like a raffle, but it's going to happen with sporting events. Eventually, we're going to have a robust prediction market. I know Augur has been working on that for years, augur.net. Really looking forward to that, where we can not only wager on sporting events and political events, we'll be able to wager on even the nefarious stuff, which will turn out to be not so nefarious. I've talked with some friends and family about how, many years ago, I think Congress and maybe DARPA had proposed to DARPA a prediction market type of scenario for terrorist type events. So let's say, we'll just pick a city, Tel Aviv. What are the chances that at least 10 people die by the end of tomorrow due to a terrorist attack? Well, if there was a counterparty who put up a good deal of money that was left there hanging at great odds, and someone that was close to a potential attack had information that that attack was going to happen, they would likely purchase that on the sly, unbeknownst to the people that are actually going to go and commit the terror attack. This would move the markets, and then the intelligence communities, both here and abroad, could react to the uptick in the markets, and not just the intelligence communities, but actual people. So if you saw, if you're traveling around the world, you're going to a dangerous place like Chad, let's say, and you see that the market on some of the cities in Chad are ticking up quickly, you'd be less likely to go out or even to visit, for that matter. And so the good and the bad is coming. I consider that particular scenario to be a good one, but of course, with all free tools, you'll get good and bad. There will be bad things, but it's only bad in the context of how you frame it. Sometimes, I mean, there are actually immoral things that will go down, but for all the bad stuff that will happen, which I think will be small. I think in general people are good. There will be resistance and actions taken, in the realms that we can take action against them, to stop things like that. So anyway, don't want to get too far off base with this stuff, but this is how you would generally build a provably fair system.